In this video, we're going to use the PrimerBlast web applet tool to design PCR primers for use in amplifying our DNA sequence. Now, in an earlier video, we used the translate tool to look at how we could get the amino acid sequence from a section of DNA. So we're going to use the same DNA sequence this time and use it as an example to look for our PCR primers. In the earlier video, we'd found the open reading frame, which I've now highlighted on my DNA sequence in red. We used the link up here, but now we want to amplify up this red part of my DNA so we can use that in a cloning experiment later on. Now, PrimerBlast is a great tool. It's going to go through our DNA sequence and it's going to report back optimized PCR primers that we can use in our experiments. What it needs is the DNA sequence pasting in here, and it's very useful to tell it the ranges where you'd like the primers to be designed. So we want the forward primer to be in front of our open reading frame, and we want the reverse primer to be at the end of our open reading frame. Now, the computer needs to know where that is on the sequence that we're giving it. So we're going to go back to the DNA sequence and we're going to work out the range of nucleotides that contain the forward and reverse primers. So here's my DNA sequence. I'm going to work out how many nucleotides I've got written down. So to do that, I'm going to highlight the whole thing and I'm going to click on Review up here and then Word Count. So Word Count tells me that there are 558 characters. That's pretty good. So this first bit, we're going to do the same again. Goes to 51. And this second bit to the end tells me there's 504. So now I know that 1 to 51 contains that sequence, and 508, I'm going to double check that, to the end, well, I've forgotten already, so let's double check. 558. 554, see, it's always worth checking. That region of nucleotides is that region there, which is outside of my open reading frame. So if I tell protein parameters to use those two areas, it's going to return primers that would amplify and bind in this section and in this section. Now, by convention, the DNA sequences are written 5' to 3'. So let's go and put those numbers in. Now, back in my PrimerBlast, I've put in the forward primer region and the reverse primer region. I've put in the nucleotide sequence from my example file. The last thing to double check is the PCR product size. Now, from the earlier video, we know that there was 150 amino acids. That also means that the maximum size that I'm going to need is around about 450 to amplify up my region of interest. Now, we've got plenty of scope in there, so our PCR product size somewhere between 70 and 1000 is really going to nail it, but let's narrow that down. So we want to say it's at least going to be 450 to over 1000. Now, if your nucleotide sequence is quite long, you might have to change this maximum output for the product size. You can also change the annealing temperatures that you want to optimize for. So we've got a minimum of 57, a maximum of 63, and an optimum of 60. So now we're ready to go. We scroll down to the bottom and we click on Get Primers. Now, that query took about 5 minutes, so I'd stopped and restarted the video. But what you get then is the output shown here. So it's brought up 10 different primers that we can use, and if we scroll down on the web page, the details of them are here. So we have our primer pairs. Here is the first primer pair with a forward primer and a reverse primer. It's given us the regions in which it's going to bind to the DNA sequence that we put in. It's given us the melting temperatures, the GC content, and the self-complementarity. That's how much it will bind back upon itself. That wants to be nice and low. So there we go. We've produced our first set of primers that we could then go and trial in our PCR experiments to amplify up our gene of interest.